Alright, so welcome back. We're going to have one more discussion here. And this particular discussion is going to be about volume. Now, keep in mind that with a lot of these measurement pieces, one thing that's maybe missing for some of you is the numbers. I'm not using any numbers because what I'm really focusing in here is the theory behind what we're really doing. And I think that if you can understand that piece, the numbers themselves are easy to deal with. You've been doing multiplication for years. The other parts and pieces of this are what are kind of difficult for a lot of people. So I'm going to start once again with just a shape of some sort, in this case a prism. This is a triangular prism, and what we want to talk about is how do we find the volume. And I'm going to say the volume is the base times the height. And I have height in quotes because it could be a length, it could be just some distance. It's really all we're concerned with, because if I set this down like this, what's the height of this thing? We're used to thinking height being up and down measurement. Well, the up and down measurement is actually part of the base. So the height that we need is actually from side to side in this instance, which is why I put it in quotes, because if I turn it upright, now you see the base, and the height is up and down. The height that we need is up and down. So that's why I put height in quotes, is because you're really wanting to find that length. How far is that base continued? Here's the base, right? And that base is repeated all the way down this way. You say, what do you mean when it's repeated? What I mean is that think of it in terms of it being slices. Like this is a loaf of bread, and you're going a triangular piece of bread, loaf of bread, and you're cutting the bread. Each slice of the bread up and down is going to be a triangle. Okay? So if you're talking about a cylinder, right? Well, how do you find the area or the volume of a cylinder? Well, once again, you have your base, which is a circle, and then you have your height, right? Which goes this way. Now keep in mind that what you're dealing with is this basic piece here, this disc, if you will. This is your base shape, and all you're doing is you're repeating that as you go through the object. So if you wanted to find the volume of this thing, it is the area of the base times the length that it is used, that is repeated, which is in many cases the way depending on how we orient it's the height of the object. And we can do this with lots of things. So it still works the same with this object. It's still base times height. Now, it does actually change a little bit when you get to other interesting objects. In this instance right here, we're dealing with it being a cone. Well, great. How do you do that? It's not the same shape anymore, is it? It's not the same piece all the time. But what is also interesting here is that we still have that circle base, right? So it's still volume, right? So here we had the volume of a cylinder, which was pi r squared times height. We had the volume of a triangular prism, which was 1/2 base times height. Oh, yeah, there's that height piece, right? Because that's how you found the area of that piece was 1/2 base times height. That's the area of a triangle. And then I guess we got to do length for the length of it, right, to keep different pieces. The volume for a rectangular prism, which was length times width times height. Oh, all these are different, aren't they? Which is why I go back to the idea of saying base times height. And then we get to this idea of the volume of a cone and other objects, because we also have, say, a triangular pyramid or a square pyramid. Well, square pyramids and triangular pyramids and cones are actually all the same shape. They really, really are. Still base times height. So when you talk about these partial pieces here, in this case right here, and you can go through and do this deviation process if you so desire, it's 1/3 pi r squared h. It's a third of that one. Now you notice that they're the exact same size that way. What we're saying is that if I were to take water, okay, and I were to empty both of these out, I can't do this, of course, I'm sitting on my desk and in front of a camera, but if I were to take this and I were to fill this cone with water, I could fill this cone with water, pour it into there 3 times, and I would get the cylinder. That's what we're referring to. That's why that 1/3. And it works the same for all of them. It works the same way for the triangular prism, okay? I just put that back in there so you can see the color. Once again, you notice that the bases are the same, right? Look at that, same base. And you would take 3 of these triangular pyramids to fill up this triangular prism. And it works that way. And again, notice, I don't know if you can see this very well, but notice that they are the same height or the same length, depending on how you're questioning that. So again, when you're dealing with these shapes here, the volume of these pyramids or these cones, can I do this? Kevin, I put cones in quotes because we're also talking the pyramids, is 1/3 the base times the height. Okay? And that's how we're going to do those. Not really, those formulas really kind of take care of all those for you. Regardless, I can give you hundreds and hundreds of shapes. And if you remember that your cones, quote unquote, are 1/3 the base times the height, and that your volume of your other objects, they don't have to be regular, they just have to be prisms essentially, are base times height. That can get you through 99% of all the problems you're going to need to deal with. Keep in mind that this is a right pyramid, a right cone. It doesn't really change a whole lot when it kind of gets offset a little bit. So instead of going straight up, if it's off to the side a little bit, it actually still works. Anyway, take care, be good, reach out with questions and comments as you have them, and keep mathing on.